Hello and welcome to the latest C2GLearn webinar from the Carnegie Climate Governance Initiative. My name is Nick Harrison, and for those of you not familiar with the Carnegie Climate Governance Initiative, we are a time-limited, foundation-funded initiative of the Carnegie Council for Ethics and International Affairs, and our mission is to catalyze the governance of climate-altering approaches, in particular for large-scale carbon dioxide removal and for solar radiation modification. And to find out more about these topics and to view other episodes of C2GLearn, you can visit our website at 3ws.c2g2.net and scroll down to the C2GLearn button further down the page. Now, today we're going to learn about how the Working Group 2 report of the IPCC's 6th assessment addresses large-scale carbon dioxide removal and solar radiation modification, and explore what, if any, implications this might have for governance. Now, the new report, which was published in February 2022, is the second of the 3 working group reports, and you can find briefings and other resources on all 3 of these reports, also on our website. Scroll down the page to the IPCC button from the homepage. Whilst the first working group report, published in 2021, addressed the physical science of climate change, this second working group 2 report looks at climate impacts, adaptation, and vulnerability. And at over 3,600 pages for the main report itself, there is a lot to take in. But fear not, because to help us on our learning journey and to help us understand how the report covers CDR and SRM, I'm delighted to welcome 3 international experts who are one of the 270-odd authors of the report. They're going to tell us more about how CDR and SRM is covered and give you the opportunity to ask questions. So if our speakers could join us and switch on their videos. They're joining us live today from Netherlands, India, and South Africa. First up is Martin van Elst. Martin's director of the Red Cross Red Crescent Climate Center, and he holds positions at the University of Twente in the Netherlands and Columbia University in New York. He's co-editor-in-chief of the journal Climate Risk Management and an IPCC coordinating lead author. Secondly, Aditya Mukherjee is principal researcher at the International Water Management Institute, and is a member of the consultative committee of the FAO Groundwater Governance Project, and is a coordinating lead author for the Working Group 2 chapter on water. And Christopher Trissos is director of the Climate Risk Lab and the African Climate and Development Initiative based in the University of Cape Town. And Christopher was the coordinating lead author for the Working Group 2 chapter on Africa. So we'll begin today with presentations from each of our 3 speakers, followed by a Q&A session to give you the opportunity to pose questions and to receive answers. The presentations are pre-recorded, so you can watch them again after the event from the dedicated page on our website. Whilst you're watching the presentations, feel free to start adding questions into the Q&A box below, and then we have around 25 minutes to half an hour to put those questions to the speakers. So I'd like my colleagues now to start the video, and we'll take it from there.
Climate and Disaster Resilience at ITC, University of Twente, the Netherlands. I'll quickly be taking you through the main conclusions of the IPCC Working Group 2 contribution to the 6th assessment report. Let me share my screen. Obviously, I won't be able to do justice to everything that is in the report. It is a massive undertaking that took several years to complete. The work of 270 authors and almost 700 contributing authors. Summarizing more than 34,000 scientific papers, the report went through several review rounds with over 62,000 review comments that were responded to line by line. And then last month, we ended all of this with the summary for policymakers being approved by all UN governments, line by line, so that what we end up with here is really not just a reflection of all the science, but also a consensus among all governments of what that science represents. And I'll give you a snapshot of that in the next 10 minutes. But please go to the full report to see the wealth of information that is collected there. And that wealth of information is a pretty bleak picture. The main headline conclusion is this: the scientific evidence is unequivocal that climate change is a threat to human well-being and the health of the planet, and that any further delay in concerted global action will miss the brief, rapidly closing window to secure a livable future. When, with my team in the International Red Cross Red Crescent Climate Center, we were devising a way to tell the story of this report to general audiences, we commissioned cartoonists to briefly describe its main conclusions. And this was the sort of overall catch cartoon for what the report was, an atlas of doom. It looked, well, it's actually not funny at all, but it is an apt description of the bleakness of the report, echoed on the day of its release by the UN Secretary General Guterres, who actually called the report an atlas of human suffering. But I want to emphasize that it's not all just bleakness. The report is also about solutions. What can we do to adapt? How can we better deal with the rising risks that are coming our way? But importantly, of course, also, and that's what the recent Working Group 3 report was about, it adds to the urgency of still reducing emissions, because we can still limit temperature rise from going to the levels where we see that the risks are really getting out of hand. Okay, let's take a look at those main conclusions. The first is that the impacts are already dangerous and widespread around us today. And it includes disruption in nature, such as these dying forests in California, but also impacts on the lives of billions of people around the world, despite efforts to adapt to what's already changing around us. And everyone is feeling that today. We estimate that over 3.3 to 3.6 billion people live in hotspots of high vulnerability to climate change today. And in that sense, we are seeing that climate change is already affecting people, but of course, not just because of what's changing in the climate. It's a combination of those rising risks from the atmosphere and the ocean with how we are shaping risks by other patterns: poverty, inequality, unsustainable use of natural resources, and increasingly urbanization, where assets and people are being concentrated, sometimes in highly vulnerable places, and not always taking into account the risks even of today's climate, let alone how it is changing. We have an opportunity here to reduce risks rather than just see them rise as they have often been today. In places of high vulnerability, climate change is already contributing to humanitarian crises. And one of the challenges here is that the potential is that the current impacts actually aggravate vulnerability to future shocks. And that links to a more broad pattern of risks becoming more complex and more compounded. Whereas originally people thought of climate change as a predictable thing for the future that we could just anticipate and adapt to. Say 10 centimeters of sea level rise, you add 10 centimeters to a seawall and you're back to the old level of safety. What we're seeing around us clearly is that risks are getting more complex and compounded. And that includes combinations of hazards that are more difficult to manage. So in the Netherlands, for instance, my own country, we thought of sea level rise, and then we were confronted with increased runoff from our rivers. So we needed to create more space for those rivers. But then suddenly 2 years ago, with a very hot and dry summer, so suddenly instead of getting rid of the water, we actually needed to keep the water in. But what we're also seeing increasingly is that those risks are cascading through sectors and regions. So for instance, failed harvests in one place, leading to rising food prices, and then food insecurity in other places. We've seen all around us the massive shocks translating through global supply chains after COVID in these recent years, but equally with climate shocks. And we've seen that with the floods in Thailand 10 years ago, for instance. And importantly, what we're seeing now is that responses themselves are becoming risks. And we're seeing that with maladaptation, where some solutions may work for one hazard, but not for another, or may work for a while or for limited extremes, but actually increase vulnerability to bigger problems or longer term trends. We're also seeing winners and losers. For instance, if you do irrigation to keep agriculture going somewhere upstream, and you're taking water away from people downstream that are also facing rising climate variability. So all of those patterns of maladaptation are becoming a bigger concern, and we're already seeing more of that happening. But we're also seeing side effects of mitigation. For instance, biofuel production that may compete with food production, but also affect biodiversity. And of course, the same question around risks of solar radiation modification are also raised in the report. This complexity of risks is an increasing character of the climate risks we're facing today, making it harder also to estimate quantitatively what exactly we're facing. But the concerns have clearly gone up. And that then also means that the risks are worse than we thought before. And every small increase in warming increases future risks. These are the infamous burning embers that for unique and threatened systems, extreme weather events, the distribution of impacts, but also the global aggregated impacts, as well as the risk of big tipping points, large scale events that can really dramatically alter the climate irreversibly, where we looked at how these risks are evolving. And compared to our previous assessment 7 years ago, all of these risks are coming at us faster than we thought before. So temperature has continued to rise. Greenhouse gases have continued to accumulate in the atmosphere, committing us to more continued global warming. But also at each level of global warming, each of these risks is coming at us faster. And importantly, many of these risks are facing limits to adaptation. And that's particularly depicted by the purple, which was only evident in 2 of these bars in the previous assessment, but now becomes visible in all of them if temperatures rise certainly above 3 degrees, but in some cases already above 1.5 degrees. There will not be any ways to adapt if we reach those high temperature levels. And that has huge implications in terms of heat stress, water scarcity, food security, flood risk. We're talking about severe risks to human well-being. And there are many actions we can take, and we've seen them being effective. We've seen them taking place. And a good example are early warning systems, for instance, that have saved millions of lives over the past decades. That action has increased, but the progress is uneven, and we're not adapting fast enough compared to how fast the risks are rising. And importantly, as I already showed you with the burning embers, there are limits to adaptation. Even effective adaptation will not prevent all losses and damages in the coming decades. Above 1.5 degrees, some natural solutions may no longer work. Similarly, lack of fresh water could mean that people living on small islands, and in cases of dependency on glaciers and snow melt, people may no longer be able to adapt in those places. And by 2 degrees, it will be challenging to farm multiple staple crops in many of the current growing areas. These are severe risks that will at some point become unavoidable. And their impacts will be particularly severe for the most vulnerable. Again, this is one of those cartoons interpretations of what the report is saying. Of course, not an IPCC illustration, but it signals that in many cases where people have the resources, they'll be able to adapt much further and faster than people already suffering the consequences today. And it also means that action is highly urgent. There is a question about what we do in light of the evidence also coming out of the IPCC Working Group 3 report on mitigation this week. What we do about the temperature trajectories by keeping greenhouse gas reductions, by reducing greenhouse gas reductions much more quickly than is happening so far, to make sure we can still stay on those temperature pathways. But equally, we must better manage risk. It is not good enough to just count on development as usual, keeping people safe from the increasing shocks that we're already seeing today and that we're expecting in the future. And once again, some of the current shocks may aggravate vulnerability and thus increase vulnerability to future shocks. And that means that if you're in one of these downward paths with rising temperatures and rising risks, you may not be able to get on the pathways towards climate resilient development at all at some point. And this is the short window of opportunity that we were describing about, which is both about the temperature pathways that we must protect by reducing greenhouse gas emissions quickly, but also the development pathways that we must choose in how we build our cities, how we divide up the resources in the world, and how we collaborate and govern the risks that are facing us now in almost all sectors of society everywhere on Earth. Again, a bleak picture, but also a picture of hope in terms of those solutions still being available and at our disposal. But it requires transformational change in many sectors in our society. Let me leave it there. Thank you very much for your attention, and I'll hand over here to my colleagues who will take you into more detail on carbon dioxide removal and solar radiation modification. Thank you.
Good morning, good afternoon, and good evening. My name is Dr. Aditi Mukherjee, and I was one of the coordinating lead authors for the water chapter. For today's webinar, I'm going to present some of our main findings on carbon dioxide removals and trade-offs with water and food security. To be very honest, this was a relatively small section in the water chapter where we had looked at not only carbon dioxide removals but also other mitigation measures, and we had tried to see in that particular section what were the trade-offs as well as synergies with adaptation and mitigation, and how various mitigation measures including CDRs actually helped with or was negatively impacted water and food. But today for this presentation, I'm going to talk about the 3 main CDRs that we had briefly assessed in the chapter. So overall, our chapter had concluded that many mitigation measures, and this I have included in the brackets, was not there in the chapter specifically, including CDR approaches and technologies, have considerable water footprint, high confidence, which must be managed in socially and politically accepted ways to reduce the water intensity of mitigation while increasing synergies with sustainable development. Medium evidence, high agreement. So this was our one of our key conclusions from the water chapter when it came to synergies between mitigation and adaptation. We looked at 3 CDR approaches and technologies. The first is the bioenergy crop, and our finding was that bioenergy crops by themselves can limit global warming by the end of 21st century to 1.5 according to one study, but it can potentially also double the global area and population living under severe water stress compared to the current baseline. Basically saying that yes, you can grow bioenergy crops, but then if you do so, it would be seriously compromising on water security, and there is also a constraint to how much land is actually available. Through these bioenergy crops can significantly impact food prices via demand for land and water. So there are a few studies that looks at the impact of bioenergy crops on food as well as water prices, and the impacts were largely negative. We also briefly looked at forestation and reforestation, as did many other chapters in the working group too, given that forestation and also some of the related approaches also have a very clear adaptation co-benefit. What we said was it is obviously a hugely popular tool for mitigation and CDR, with some very optimistic estimates saying additional 5 billion hectare of canopy covered in suitable locations could store 205 gigatons of carbon. Basically, this whole thing about afforestation and reforestation as the silver bullet. Obviously, this is hugely contested. What our chapter found and assessed from the existing literature was that if done at inappropriate locations or with inappropriate species, actually the trade-offs between land biodiversity and water resources can be pretty high and pretty negative, and it can have a lot of negative impacts on local population, particularly indigenous populations who often depend on these forest resources. Another one of these global assessments, such as the global assessment on forest and water, which we also cited in the water chapter, said that afforestation and reforestation should be concentrated in water abundant location where transpiration can potentially be captured downwind as precipitation. There is a distinct field that water hydrologists have been working and foresters have been working for a long time. It's called forest hydrology, and there's a lot of literature around there around appropriate siting of forest and which forests are good for hydrology, or which forests actually have negative impacts on hydrological cycles. So I think this is when forests are discussed in the context of mitigation of CDR, it's very important to bring on board that huge, like centuries old knowledge actually that we have around forest hydrology as well. Overall extensive BECS, that's bioenergy, also bioenergy and carbon capture and storage, and afforestation, reforestation deployment can actually alter water cycle at regional scales. And there is evidence that it can happen once these are extensively deployed for afforestation, reforestation. We already have evidence of alteration of water cycle at regional levels. The third technology that we looked at very briefly again was direct water capture. And again, here some of the projections, and I know that Working Group 3 has dedicated a lot more time and attention to all of these CDRs. But overall projection shows that could reduce emissions by up to 3 gigaton per year by 2035, equivalent to 7% of 2019 global emissions. But can increase net consumption of water by 35 kilometer cube in a year in a low overshoot scenario. And capturing 10 gigaton of CO2 could translate to water losses between 10 to 100 cubic kilometers, depending on the technology deployed versus climatic conditions. Similarly, like DAC technologies remain untested, can also significantly impact food prices and demand for water. And this all in the context of a time when we know that, and this is where water chapter of working group 2 clearly shows that climate change has already impacted all components of the water cycle. And we also know, based on our observed data of over more than a century, that some parts of the world are getting wetter, some are getting drier, and some of the results in our chapter shows that, and studies have already showing that approximately 4 billion people are already experiencing water scarcity for at least a month in the year. And not all of these is obviously related to climate change. Some of it is, but it's also related to a host of non-climatic factors, water demand, demographic pressures, governance, and a whole host of it. And water scarcity is not only about water quantity, but it's also about water quality. It's also about hazards. It's also about floods and droughts. So water scarcity is kind of water scarcity is just one manifestation of water insecurity, because water insecurity covers a lot more of these. So therefore, chances are that more than half of the world's population are not only water scarce, but they also suffer from water insecurity. And that's already happening now. What's also important is that as we said, that since 1950s, almost half a billion, 500 million people have seen changes in parts of their world getting wetter. 163 million have seen their parts getting drier. So overall, a large proportion of humanity are experiencing climate change through changes in the water cycle. And this is only projected to intensify. And here the main point of this graph, of this figures, which is also from the chapter 4, is that not only are precipitation changes happening, but the associated uncertainties are also quite uncertain, and they're also projected to increase with global warming. So most of our work kind of depends on the central estimates, and we are showing the central estimates are which averages out between the various scenarios, etc., actually may not always be the most correct indicator of, or the current correct, yeah, this indicator of the changes that are in the offing, because there are higher uncertainties, the changes could go either way, and those uncertainties actually make it even harder to plan for water resource management in the future. And add to that the additional pressures from CDR, water pressures, means that we have to be really, really careful on what is planned where. So this map actually shows that the kinds of policy challenges that we have globally, and what these different dots really mean is that areas with these gray dots mean that there is a low water scarcity, but also the uncertainty in the future is also stable or predictable, while in a very high ones are where water scarcity is already high, but the uncertainty in future projections is also quite high. So those are the areas with high challenge. To sum up, again, bringing it back to the issue of CDR, governance of CDR must ensure, and now we know that CDR is one of those things that is necessary to keep ourselves within net zero targets. So governance of CDR must ensure water and food security are not compromised. So some of the questions going forward is who decides which approaches and technologies are deployed, who designs and implement them, and where? Are water footprints and food impacts understood and modeled? For forestry, for forestation, there is just wide range of literature already available, or where those forests are suitable and where they are not. Are we using those in answering some of these location questions? Also importantly, and working group 2 is quite vocal about equity in climate impacts, lack of equity in climate impacts, and how will those who are negatively affected have their voices heard. So it is also clear, therefore, that there is a need for multi-level polycentric governance with multiple layers of players, each accountable to one another, and particularly with participation of local communities in CDR decisions and deployment. To conclude, water and food security issues, water and food people must have a seat at the CDR table, along with the indigenous communities and others who are directly affected.
Hi, I'm Chris Trisos, and I'll be talking about the key messages regarding solar radiation modification from the recently released IPCC Working Group 2 report. First, what is SRM in the IPCC report? SRM refers to proposals to increase the reflection of sunlight back to space to counteract human-caused global warming and some of its harmful impacts. The most commonly researched SRM proposal is introducing aerosols into the stratosphere to create a thin veil of particles to reflect incoming solar radiation back to space and offset global warming. So in what context does the IPCC Working Group 2 report consider solar radiation modification? It does this in the context of climate change risks. First, to define risk from the IPCC perspective, risk is the potential for adverse consequences to human or ecological systems. And these risks arise from the interaction of the physical climate hazard. You can see in the graph on the right-hand side of this slide, the physical climate hazard, which could be a drought or a flood or a heat wave, the systems that are exposed, such as urban areas or agricultural areas, and the vulnerability of those systems, such as their capacity to adapt to the hazard and the exposure. Importantly, in the sixth assessment report, the IPCC has updated this risk definition to also include the risk from adaptation and mitigation and other responses to climate change. And so it's clear that the severity of climate change risks is determined in part by how we respond to those risks as a society. And responses can reduce risk, but they can also increase risk or create new risks. For example, large-scale deployment of bioenergy crops or afforestation as a mitigation strategy can actually increase risks for water security, for food security, and for biodiversity. And within this context, the IPCC considered solar radiation modification in the Working Group 2 report as a climate change response that has the potential to reduce climate change risks, but also increase risk or introduce new risks. So first, to start with the climate hazards part of the risk. Most SRM research, it's assessed, has focused on climate hazards, and there's been much less on overall risk. The effects of SRM on climate hazards are highly dependent on the deployment scenarios, but in general, SRM approaches have potential to offset warming and ameliorate some climate hazards. However, there would be substantial residual climate change or overcompensating climate change at regional scales and at seasonal timescales, and this assessment is made with high confidence. SRM also does not address the root causes of climate change. So solar radiation modification would not stop carbon dioxide concentrations from increasing in the atmosphere, and it would not stop the resulting ocean acidification under scenarios with continued anthropogenic emissions. For this reason, there is high agreement in the research literature that for addressing climate change risks, SRM is at best a supplement to achieving sustained net zero or net negative carbon dioxide emissions levels globally. So what is the assessment saying about SRM's ability to address climate change risk? It's not dealing with the root causes of climate change, but can it reduce climate change risks? And in this context, there's much less research on SRM's potential to reduce risks from climate change compared to the focus purely on the physical climate hazards. There are large uncertainties and knowledge gaps associated with the potential of SRM to reduce climate change risks. And SRM approaches, if they were to be implemented, introduce a widespread range of new risks to people and ecosystems, and these are not well understood. In the case of specific sectors, there is low confidence in the potential risk reduction for crop yields from a deployment of SRM. For example, there may be benefits to crops at low latitudes in the tropics from reduced heat stress, but there could be negative impacts on crops at higher latitudes. There are many factors around UV and surface ozone and changes in rainfall that also affect crop growth other than heat, and these need much more research in an SRM deployment context. There's limited research on health, very limited research on health, especially infectious diseases that have high mortality and morbidity, and how a deployment of SRM may affect these health diseases. There's also the potential for SRM to reduce heat risk to corals, but risks from ocean acidification to ocean ecosystems would remain. There's large uncertainty in the response of terrestrial ecosystems to SRM, such as vegetation productivity and terrestrial productivity in rainforests. There's also large uncertainty in how productivity of ocean ecosystems would respond to SRM. And finally, there's high confidence in large negative impacts on the hydrological cycle and biodiversity from a sudden and sustained termination of SRM in either an intermediate or high emission scenarios. Moving now to SRM governance. The report assesses that there would be novel risks to international collaboration from an SRM deployment. And this is in the context where SRM could be deployed by a small group of nations or potentially even unilaterally, and countries can have very different preferences for optimal temperatures for SRM, for cooling. And so there could also be attempts to counter geoengineer. If one small club of countries was implementing SRM, other countries may want to counter those measures. As of now, there is no formal international governance agreement on SRM research, development, or possible deployment. And the governance objectives stated range from a prohibition to enabling research and potential deployment. Research to date has been done predominantly by a small number of experts in the global north, and unequal power relations exist where research could influence SRM governance and policy decisions, but much less research is being done by those countries that are often considered most vulnerable to climate change impacts in the global south. One example of this inequity in climate change research, for climate change research generally, this is not focused just on SRM, is that only around 4% of global climate change research funding has been spent on research focused on Africa since 1990. And most of this funding for climate change research on Africa actually went to institutions in the EU and the US. The consequence of this is low levels of adaptation research in many developing countries, as you can see in this map. And so the lesson to draw from this for SRM is clear, is that many of these countries regarded as the most vulnerable to climate change need to have a voice in SRM research and be able to participate in research to inform governance decisions. Finally, the report concludes that the co-evolution of SRM governance and research, with governance staying at least a step ahead of research, provides a chance to guard against potential risks and harms, and to ensure that SRM is considered only as part of a broader mitigation-centered portfolio of responses to climate change. You can find more details on this IPCC assessment of solar radiation management by looking at Chapter 16, specifically the cross-working group box on solar radiation modification at this link. Thank you very much.
So thanks to our three speakers there by the magic of pre-recording. And if our speakers now would like to rejoin us on the live stream. Here's Martin, here's Chris, and do we have a DT2? Excellent, great. So we have around 30, 35, 36 minutes for questions. There's a couple of questions gone into the Q&A box already. It's a complex topic, and we're dealing with two quite distinct areas here, carbon dioxide removal and solar radiation modification. So we'll try to strike a balance between the two. If that a lot of that was slightly over your head, don't worry. There's actually some resources on C2G's website which introduce sort of a more rudimentary understanding of some of these techniques and some of the challenges that they raise in relation to governance. So once again, you can visit and explore 3wc2g2.net, and hopefully that answers some of your questions. But in the meantime, we have a fabulous resource at our disposal here for the next 20 odd minutes. So let's make use of them, these three experts. I think if you have questions, please remember to put them in the Q&A box. So you can click on Q&A at the bottom, then add them in the box there, and I'll try and put them in to the speakers in short order. But perhaps we can begin with, we've got a couple of questions waiting already. I think these were addressed actually to Aditi. They popped up during your presentation, Aditi. So let's have a go at those first and see. So this one's from Sean Fitzgerald. He mentioned, Sean says that you say that bioenergy crops can limit temperature rise to 1.5 degrees C, and is this really the consensus of scientists? So this is more a mitigation question, I suppose, in some ways, so relating to Working Group 3. But would you like to respond on that at all, Aditi, or indeed any of the other panelists?
My understanding is that this is not the consensus of the scientists. It was one study that we have cited, and we did not put any confidence language around this study. So certainly not a consensus. It's a study that was trying to see that okay, what happens if bioenergy crops is one of the major mitigation measures. I know whether temperatures can be limited within 1.5, and they conclude that that would have huge water and land footprint. So I agree. I don't think this is a consensus, and we all know that it's not either or. It's not one mitigation technology. There are no silver bullets practically. Yeah.
Great. And so this presumes, I think, going on with Sean's question, this presumes that other things will happen too. So what else has to happen if it's not bioenergy crops alone? Do you want to respond on that?
I would have to actually look up the paper and see what were the other scenarios that they had actually looked at, but their main focus was bioenergy crops. So I can come back on that. Yeah. Great,
thank you. Let's jump now to a different topic. We've got another question from Bo Frederick, which is again on CDR. Maybe I'll come back to that in a moment. And we'll just switch to a question from Pablo Suarez. So Pablo says, given the terrifyingly slow progress on mitigation and adaptation, is it reasonable to assume that SRM will continue to gain prominence in the coming years? And can you share your insights on the chances of IPCC engaging more intensely on SRM, including the humanitarian dimensions, for example? So, for example, through maybe a special report. Who would like to, Martin or Chris, did you want to come back on that?
Yeah, I'm happy to give it a first go. Well, first of all, I think it's really interesting what's happened with the topic of, well, what once was called geoengineering as an umbrella, but is now clearly separated in solar radiation modification and carbon dioxide removal, where the carbon dioxide removal is still squarely with Working Group 3 as sort of in the remit of what's feasible, but also what are the trade-offs related to the various mitigation options. SRM is covered in a cross-working group box with actually authors from all three working groups, but residing in Working Group 2 and in Working Group 3. But it's featured in the summary for policymakers only of Working Group 2, whereas I think 10 years ago, people would have thought it more as a sort of an extension of the set of mitigation options. I think people are now starting to see it more as a last resort measure to manage the rising risks driven by a changing climate, but are also more acutely aware of everything we don't know about the risks it may in turn drive, the risk of responses that both my and Chris's presentations highlighted here, which is also a new novel development in the IPCC. So I think that's an interesting evolution to observe by itself, which I think still needs to be internalized by the wider IPCC community. And it's going to be, well, first of all, up to the framing of the next IPCC cycle. Will we still have these three working groups? What special reports might logically go along with that? But to some extent, and also the scoping meeting for however those reports get set up will be very interesting to see where this lands. My personal hunch is that there is a growing number of, well, there's more literature, but also more people more acutely aware that we've got less time left, and therefore some of the more radical options are getting closer to us in a way. On the other hand, there's a broader concern about the associated risks, and that's where I think certainly this question about the risk of responses that was highlighted in the Working Group 2 report is bound to gain prominence, and that will include solar radiation modification, but likely also others, including the biofuels, for instance, that we were discussing before. So how exactly that will play out in terms of attention in the next cycle is to be seen. I have not yet heard confirmations of sort of the special reports that would be considered in the next cycle. Certainly an option. I think the whole issue of these risk of responses is bound to get more attention. And I would actually call on all scientists also to make sure we have the right research, with a particular focus on the most vulnerable places, as Chris was highlighting, because that's maybe also somewhat subsumed under Pablo's question. There's a real question about to which extent we understand these risks, but particularly for the places where it matters most. And that's where I think we've got the biggest literature gaps. Thank you.
Thanks, Martin. Chris, I don't know if you want to add to that, but perhaps perhaps you can also say something about what's changed since the past report, the AR5, and what's changed between now and then in terms of our understanding and what's in the literature as well. Or respond to the question as well.
Yeah, I think first just there will be something on SRM still to be assessed and written in the synthesis report from the IPCC that sums up all of the special reports and working group reports of the last few years. And so that'll come out this September. It is restricted to looking at the underlying working group material though. So it won't say things that have not been said in working group 1, 2, and 3. I think, like Martin, it's interesting to see, and this is also since AR5, that SRM has found a home in the Working Group 2 summary for policymakers this time around risk reduction and its potential to introduce new risks. And that's, I think, to some extent a bit consistent with how it was framed in the special report on 1.5, but it certainly, to me, indicates a shift and also a lot of government interest towards this topic around the risks from response actions to climate change. But that's also a very politically sensitive area. And so many countries are considering, such as the USA, launching large solar geoengineering research programs, largely computer simulations to better understand risks and benefits from solar radiation modification. And I think those programs will provide quite a lot of the information potentially that could be used in future IPCC assessment reports. And so I think a really important shift that needs to happen in some ways for that research, and that's identified in this AR6 assessment, is we've seen a lot of research on SRM impacts on climate hazards, and that's necessary. We don't know enough about that, but there's just so much less research on the risks to people and ecosystems. And I would argue ultimately that any kind of a design space for SRM should be considering the risks to people and ecosystems primarily, and the hazards are just one part of that picture. It shouldn't be primarily targeted at the hazard. Thanks.
Thanks, Chris. If I might come back just with another quick follow-up question. You mentioned in your presentation about the sort of the lack of developing country research, and particularly in a nascent field such as SRM and its impacts. Those challenges about securing sort of more understanding about impacts on people and ecosystems in particular, perhaps any suggestions or insights from your work on how that might be strengthened, how those issues might be addressed? Obviously, there are capacity constraints in different areas of the world, but any thoughts on that from your research and your assessments?
Thanks, Nick. I think one major thing that can improve that situation is more funding for climate change research going directly to researchers in developing countries. A lot of research at the moment flows indirectly, and projects that fund researchers in developing countries directly and therefore give them more freedom to set their own research agendas in line with local questions about climate risk, adaptation, and mitigation, I think can be very, very powerful. I think something we don't consider perhaps enough on the natural science side of the climate change discussion is the people who are empowered to ask the research questions are those who are also empowered to shape the research answers. And so to fund a more inclusive and diverse group of researchers on an increasingly important topic like SRM is a first big step towards that goal of having a more inclusive perspective on the problem. I think a second major thing that can happen is increasing global north, global south partnerships in research. We're starting to see that become more prominent in the SRM discussion, but I think it's also that those partnerships should be ones that are equitable. So it's both global south researchers visiting well-resourced institutions in the global north, but also the other way around, people visiting global south institutions and really getting a good understanding of their perspectives on the problem and investing in capacity building in those institutions in the global south. Thanks.
Thanks, Chris. And if I might pivot back to carbon dioxide removal now, going back to an earlier question from Bo Frederick, I think addressed to you, Aditi, but by all means others can answer as well. How much nature-based CDR and technology-based CDR will be needed to reach 1.5 degrees C is a question that's posed, and the impact that will have on things like GDP, or indeed if we get into an overshoot situation, as was mentioned earlier, what implications might that have for consideration around the combinations or the scale of CDR that might be required? Do you have any insights or thoughts on that, Aditi?
No. Unfortunately, I don't, but I'll defer to my other co-panelists. I think this is something that Working Group 3 has dealt with in more detail than we have. Much of our focus was on looking at synergies and trade-offs between mitigation and adaptation, and CDR being one of those categories of mitigation that we looked at. So we really focused on how these can have maladaptive outcomes in terms of adaptation. So, but yeah, Martin and Chris, they may have more insight into that. But water chapter was very specific about how all of these affect water and food security.
Thanks, Aditi.
I could come in briefly.
Yeah, go ahead. Please do.
I think when we talk about carbon dioxide removal is essential, and messages that have come out of the Working Group 3 report, and then I'm now speaking from a Working Group 2 report on risks and adaptation perspective, I think it's very good to keep in mind what we mean about essential. So there's using carbon dioxide removal to offset very difficult to abate emissions, and using CDR in that context to reach net zero. And then there's using CDR to offset emissions that could be otherwise reduced from reduction of, for example, coal-fired power stations, and saying, okay, we've got to use nature-based solutions to soak up the emissions from coal-fired power stations. That is not a net negative carbon dioxide removal, right? The Working Group 2 report is very clear on the difference between just carbon capture and actually removing carbon from the atmosphere, storing it, and so you've got a negative emission. And I think when we talk about nature-based solutions in that context, when we talk about things like reforestation, so that's restoring forests on what was naturally forested land where there's been forest deforestation or forest degradation, Working Group 2 says that's a good idea. When it's doing things like afforestation, which is planting trees, often not native species, but in the context of Africa, it might be pine trees or eucalypts that are being planted on grasslands and savannas as part of projects to soak up emissions from fossil fuel sources that could be reduced in other ways, then that is a bad idea. It comes with a lot of risks, like Aditi has mentioned, to water security, to food security, to biodiversity. And as global warming continues to rise, those projects are also highly sensitive to high emissions. Those trees can die from drought, they can release carbon through wildfires, you disturb the soil carbon base and have higher biogenic emissions. So there's a very big solution space for nature-based solutions, but there's also a lot of risk involved in those. And I think, just to emphasize again briefly, it's really important to talk about what do you mean when you say CDR is essential, and that focus is on hard to abate emissions, not just using them as a way to offset other easy to reduce carbon emissions. And the second one is they also have their limits, nature-based solutions. They bring quite a lot of risks if you do them wrong, like afforestation. and you can't rely on them necessarily up to very high levels of global warming. They can become net sources of greenhouse gases instead of net sinks. Thanks.
Great. Thanks, Chris, for that additional comment.
Maybe one small addition, if I may.
Please go ahead. Yeah.
One area where I think Working Group 1 already pointed out that it will be essential to have negative emissions is if we do overshoot and we want to get back to 1.5. But I think one thing Chris also underlined just now is that that will come with significant risks. First of all, with the scale of deployment of negative emissions you might then need, but also the risks along the way in terms of those solutions possibly having other side effects, other risks to biodiversity, food security, et cetera, to water, but equally possibly even the risks in terms of safety of those actually being sustainable mitigation options. So I think there's a lot of warning signs about not counting on that as a get out of jail free card in the case of overshoot scenarios. And I think Working Group 2 is particularly underlining the risks that we'll face on such pathways.
And thanks, Martin, for that. On that, if I may pivot on that issue of risk, we had a question from Karin Zaunberger, which initially was focused on the bioenergy topic that DT raised. So considering the potential heavy impact of large-scale deployment of bioenergy measures on food and water security and on biodiversity, as you had mentioned, DT. And this is a similar case for perhaps for SRM. Can it be considered a solution? So is there, considering that there are risks posed by some of these approaches, is there a point, DT, where we might say, no, this isn't a solution at all and we should stop even thinking about it, stop exploring it? Or are there processes, decision support tools, policies for better governance to help make decisions, to help policymakers make decisions about which might be appropriate to pursue or to even deploy? Any thoughts on that around the governance processes that might help us to better manage those risks?
Yeah, in the context of CDR and now given our levels of emissions, I think it's hard to rule out anything as a solution. But having said that, we cannot just prima facie rule out that this cannot be a solution, but neither can we just use global models to say this is a solution either. I just feel that there is a need for much more differentiated, locally specific work that needs to go in, say for in case of bioenergy, like 10-15 years ago when this entire bioenergy rush started, I remember discourse in India that there are these, the Indian census classifies certain land as wasteland. This is a British legacy. The land that they did not get revenue from was classified as wasteland, and that kind of continues. So there is this perception among policymakers that wasteland is literally wasteland, but the reality is that some of the poorest people, landless people, nomadic herders, they actually use those so-called quote unquote wasteland as their main source of livelihood. And what started happening was these large scale jatropha plantations, which is a indigenous oil bearing tree, shrubs, and like basically overnight these wastelands were getting converted into these plantations, private sector coming in. And what was really happening was livelihoods of some of the most marginal people were getting affected. So I think around that time, there was a lot of awareness around what's happening. So similarly, I think these issues are very, very local, and there needs to be a series of studies, modeling, of course, to look at the future impacts, but also I think more detailed social science kind of studies that looks out who are the winners, who are the losers, who basically is kind of benefiting, who is being deprived. So I think those kind of things are needed. So neither can we say with a blanket statement, this is not a solution, or that this is the solution. It's obviously way more nuanced. It has to be way more nuanced.
Thanks, Aditi. I don't know, Chris or Martin, do you want to come back on that point as well? In terms of, perhaps Chris, in the context of SRM, you mentioned in your slide something about the co-evolution of SRM governance and research, ensuring that, for example, governance stays one step ahead of research. Is there, can you explain a little bit more about what that might involve, or the importance of that in there?
Sure. So I think first on the carbon dioxide removal, I just completely support what Aditi said from an Africa assessment perspective. There's similar legacies of people using ancient local ecosystems, grasslands and savannas that are viewed from other perspectives as degraded forests, and those are then regarded as available for carbon dioxide removal approaches. I think in a South African context, there's an increasing move towards nature-based approaches rather than nature-based solutions to highlight how they need to be locally led and assessed in a local context, so that they're not just sort of presented as these global solutions. On the SRM side around governance, I think a few things there. First is coming back to the research point. I think if we're having SRM as an inclusive global conversation around governance, there does need to be resourcing for developing countries on research, partly because some of the research concerns that are raised, that conversation. In terms of the governance staying one step ahead, I think what is being said there really is around sort of the concern expressed by those in the research literature that SRM be considered as part of a mitigation and adaptation centered, but particularly mitigation centered climate response strategy. So that in the context of governance staying one step ahead of research, that there's this co-evolution where it's able to, from a governance side, SRM be considered in any research and steps towards potential eventual deployment, that this maintains it as part of a mitigation-centered approach, and that it doesn't become seen as a primary kind of techno fix to a climate change risk.
Thanks, Chris. Martin, anything to add on either the CDR or SRM points there in relation to governance?
Well, I think it's clear that the governance discussion is needed, and I think there's a balance to be struck in terms of the investment in research and the investment in getting that governance landscape right. And part of that, getting the governance landscape right, is also increasing the literacy of a growing number of people from all the different countries and communities to participate. So in that sense also, there's research for the purpose of generating the knowledge, and there's research for the purpose of generating a community that can have the right discussions to get the governance right. I think that's also an element of the co-evolution that we could emphasize more.
Great, thanks. And on this issue of, if I might turn back to one of the issues that were raised earlier about this, there are risks. Obviously, Working Group 2 report outlines in quite devastating detail in places about the risks we face from overshooting 1.5 degrees or 2 degrees global warming. And then some of these solutions also present risks if they're not deployed in the right way. And we heard some examples there in relation to different contexts for CDR deployment, land classifications and so forth. How will policymakers go about comparing these risks to manage? Do we have any clues there? Because it's extremely complex proposition, I presume.
Yeah, and I think in practice they don't, right? And in fact, as scientists, to be quite honest, there is no easy way to aggregate and just tell people like this is the optimal mix or so. You know, if only we could provide the silver bullet, the golden mix to the world. It's not like that. It's partly weighing different types of uncertainties. My main concern is that and I think that's where the Working Group 2 report is a really big red flashing light, that we don't underestimate the range of risks involved. And in particular, the overshoot scenarios have often looked quite benign, right? You overshoot for a while and then you go back and then you're back at this safe level, right? So it sort of looks okay. You know, we have this bump for a little, but then we're okay in the end. And the answer is very clear. First of all, you'll have lost things along the way. They'll never come back. You have risks that you're not avoiding if you've been on that bump before you get down to 1.5 again. But secondly, getting back to 1.5 is not trivial. So it's also not a given that you can just overshoot and then easily get back to 1.5. And the bumpy pathways have risks of their own that you may not be able to estimate well at this point. So I think that all comes back to that underlying message from the Working Group 2 report, that we have a brief and rapidly closing window to secure that livable future. the longer we wait, the higher the risks. And the main things we can say now is that there are a whole different range of categories of risks that we all don't understand very well yet, but that are big and severe on a global scale. So it's not something to play around with.
Great, thanks, Martin. We're almost at time now. I'd like to give perhaps Chris or Aditi option for any final comments you'd like to make.
Sure. I think building on from what Martin said, one point that is really important, I think, is SRM and to some extent CDR. There are response options that carry with them a lot of risk. There are other response options across the Working Group 2 and Working Group 3 reports, so that we know there are close to no regret options. For example, rapidly reducing emissions from coal-fired power stations. That has a massive benefit for limiting global warming. It also has huge benefits for reducing premature death from local air pollution. So walkability and cyclability in cities, also something that really, really reduces emissions and improves people's health and local environments. So I think from a policymaker perspective, there is a lot of information out there around which options are less risky and which response options carry more risk. To weigh up all the risks is something that becomes increasingly difficult as we let global warming go higher and higher and higher, and we reach for these solutions where we're thinking right now they have some serious risks in and of themselves. We're still at a stage where there are a lot of options on the table that are close to no regret options that have a lot of co-benefits for people and nature. And I hope that policymakers pay close attention to investing in accelerating action in those ones. Thanks.
Thanks, Chris. Aditi, last word from you?
Yeah, I agree with everything that Martin and Chris had to say on this. And also, perhaps it's time that also that policymakers are, we often tend to think of policymakers as more and more central level policymakers, national governments, but I think we need to rethink that more at terms of local level participation. In when it comes to adaptation now, the wide discourse is around locally led adaptation, because we understand adaptation at the end of the day is a very local issue. But when it comes to mitigation, I think we are still thinking more around centralized ways of, somebody, a national government doing it. Why not also reframe the discourse around some of these mitigation and CDR in terms of locally led? So I think siting, for example, where forestation or reforestation can take place is such an important decision that can be actually taken at a more local level rather than being done more centrally. Yes, so I was just thinking that we need to actually think more in terms of locally led adaptation, but also locally led mitigation with sufficient finance and technical backstopping as needed from other higher levels of governance and policymakers. But the actual decisions must be best taken by local people who understand their environments the best.
Very good. And on that point, I'm afraid we have to close. Thanks to all our participants for your questions. I think we got through many of them, but apologies if we didn't get to all of the questions. And a very large thank you to our speakers, Martin van Aalst and Aditi Mukherjee and Christopher Trissos. And join us again next time for our next